Hey, it's Jacob. Welcome to my channel. Today I'm going to talk about Matlab and I'm going to talk about all of the basic stuff that you need to know. I'm going to start from scratch. I'm going to download Matlab and install it and then start to work with it. Alright, so the first thing to do is to download Matlab. So for that you go on the MathWorks website. I'm going to choose Matlab 2016b so that you guys can refer to this video because you probably have a higher version than that. So now you can make sure that everything that I'm going to show you in this video will work on your version. So alright, let's get started. So now the next step is to log in here. And then you can just click on download here. And now you can choose the correct license that you want to download. Show more. And now I run the installer. So now I'm going to choose login with the MathWorks account. Here you put the email address that is linked to your license. Alright, so here you need to proceed with the MathWorks software activation here. Next. 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 Confirm. Alright, so the first thing we can talk about is defining a variable. So let's start with that. Here we have defined the variable x equal 4. And you can see here in the workspace that the variable is defined and that Matlab can use it. By adding the semicolon here, it doesn't change anything. It's just going to define it just the same way as you did before. The only difference is that it's not going to display the value of the variable in the command window. Now, if you want to find something that you have already typed into the command window, what you can do is access the history by just using the up arrow key like this. And here you can see that all the history is there. So there is the two command x equal 4 and x equal 4 semicolon. And you can use them like that. It's a little bit of a shortcut and it can save you a little bit of time. Now, how can you clean up the command window? If you don't want to see all of that, you can use the CLC command and it cleans everything up. But notice that in the workspace here, the x is still equal 4. That means that Matlab consider x as 4. So if you type x here, it's going to be equal to 4. That means you haven't cleaned up the workspace. You have only cleaned up the command window. So how do you clean up the workspace? Use this command, clear all. It's going to clear all variable in the workspace. So pay attention to the workspace now. Everything is cleaned up. So to sum up, there is clear all to clean up the workspace and CLC to clean up the command window. And when you have those two, everything is cleaned up as far as we are concerned here. So I really like those two commands, right? Because they are really practical, especially for what I'm about to do, which is making a video to help all of you guys. So I'm probably going to have to use those commands very often, but I don't want to do that. I don't want to take the time to type those things, right? So what I'm about to show you is how to create a shortcut. And that shortcut I'm going to be using a lot during the video. So this is just to show you how you can use shortcuts for yourself. Now, there is a problem here. The problem is that MathWorks sometimes like to change things that actually work really well, and sometimes they don't change things that don't work. So my point is here, they changed the way to create shortcuts. This is an old version of MATLAB. I took this one on purpose so that everything that I'm going to show you will work on more recent versions, but they changed the layout a bit. So the way to define a shortcut in the new layout is a little bit different. I trust you guys to figure it out if you have a more recent version of it. It's not that difficult to figure out, but still you do have to do that work. Here I'm going to show you how to do that for this specific version, which is MATLAB 2016b. So you just go under the Home tab, New, and Command Shortcut. And here there is the label. I'm going to call it Cleanup. So here you can write something as a comment of your shortcut if you want to. I'm not going to do that. And here I type the two commands that we talked about. And I'm going to add it to the quick access toolbar. And so if I save it here, you can see that something appeared here and also here. So this is the standard shortcut toolbar, and here, this is the quick access toolbar. So let me show you how to change the icon here. You edit the shortcut, you go into the icon field, and let's change it to the uppercase C. And look at this part in the quick access toolbar. If I save it, so here it worked. Now, as you can see here, where we are in MATLAB is a little bit of a weird place to work within Windows. This is the place where we are working right now. So that's not the place where I want to work. So I'm going to move things around a little bit. I'm going to create a new folder here. And this is going to be the workspace from now on. So now let me show you how to define that path as the default path, just so that when you open MATLAB, you are going to be there. That's the path we want. Here, you can click on specify the full path to a folder. Apply. Okay, let's try it. And we're there. So MATLAB is a programming language. So the point of a programming language is to use command lines so that it can execute all of those lines one by one, right? So in MATLAB, those are called scripts. So I'm going to show you right now how to create a simple script, just so you know how to do that. The point is here, there is 3 ways of creating a script. So the first one is just, you go into the current folder here, click on it, right click, new file, script. And here you have your script and you can name it the way you want to, my script. And that's how it appears when you open the script, right? And now you can put all of the different command lines. Let me show you the second way. So delete that. Here you can just click new script here and the new script appears. And the last one is to use the command history. So the command history is where all the command lines that you wrote into the command window have been stored, right? So it's in layout, command history, click on docked. There is all of the commands that you've used in the past, right? So you can then select by holding down Control and clicking on different command lines that you want into your script, and then right click, create script, and that's it. All you have to do now is save that script and you will have like all the commands that you've selected from the command history as a script, right? So let's close that now. I'm not going to save it. I'm going to get rid of the command history. All right, so I'm not a huge advocate of the Hello World program. Hello World program, if you don't know what it is, it's just a program that displays the Hello World sentence. The reason why I don't want to do that is because I want to do something that might be useful at some point, or at least start building towards that. So what we're going to do right now is a simple program that will compute your cash flow based on your spendings and based on your paycheck. So let's try that. I'm going to use the simplest functions that we can get away with, just so that you are not getting overwhelmed by all of the different functions that are not necessary, right? All we want to do now is have the minimum amount of functions that we can get away with so that we can move forward. So I'm going to call it cash flow. Let's say our paycheck is 3,547. Now I'm doing Control S to save. Here you can see the asterisk went away. That means we successfully saved our progress. And let's say our spendings are 159. So in order to compute the cash flow, we have to subtract those numbers. So here we have computed the cash flow, and that's it. It's that simple. We're done now. The thing is, we want it to be displayed in the command window. For that, we're going to use the disp function. And here we're defining the variable named words to display. And that variable is going to be what we're going to see on the screen. So it's something like that, right? It's the word cash flow with the content of the variable cash flow, right? But how do we make the difference between those two? So here we want it to display characters, not the content of any variable, right? And so for that we use single quotation marks. And one of the good things within the Matlab editor is that you can see the difference between characters and variables. If it's in purple, that means it's not going to be used as a variable. So here we have what we want to be displayed, and here we have the value of the cash flow, right? But let's try to run that script. And in order to do that, you click here on run, or you can use function 5 to run the script. And we can see that we have an error here. So line 6, it's here. So that means that didn't work. The problem is there is an unexpected Matlab expression. Why? Because we can't put those two together just like this, right? If we're gonna do that, we have to use square brackets. And also here we have strings that are attached to a number, right? So it's not gonna work. We have to convert the number into a string. And for that, we're gonna have to use a specific variable called num2str. So this one is just gonna convert that number into a string. Now let's try it. It doesn't work here. It doesn't work because we can't use that name as a variable because it's also the name of the script. So we're gonna change the name of the script. And we call it cashflow script. And now let's try to run it. All right, now it worked. So I'm gonna clean everything here by clicking on the C cleanup shortcut that we created right before. I will come back to the script and run it again. So you see there is the name of the script here. So that means that you can run the script by writing the name of the script in the command window and it's gonna work. So let's try that. Let's write cashflow script. And you see it runs the script as well. Also in Matlab, you can use the tab key in order to autocomplete what you're writing. So here, cash flow. If I use the tab, you can select like the script available because since the cash flow script is within the path of Matlab, Matlab can see it, can identify it, and can autocomplete what you're writing. And it also works. All right. So I went real fast here, but the point here is you are concatenating different strings here. So if I can show you how it works, this is one string, this is another one, and if you put those two together with square brackets, then it is concatenating those two. You see? And that's what we did here. We converted the number into a string, we concatenated it with the cash flow string here. So this is, in my opinion, the easiest way to concatenate things in Matlab. So this is something that we're going to use a lot. So that's really important that you understand how it works. So let's clean up. Just to summarize, there are 3 ways to run a script. One way is to click on the button run here. The second way is to use the function 5 key. And the third way is to use the name of the script here in the command window. So now let's do something actually useful, which is do something based on a condition. So for example, here we have a cash flow, and what is going to happen if the cash flow is positive or is negative, right? Like the point is, if it's positive, we can display something, and if it's negative, then you can display something else, so that all you have to do is run the script, and then you will have an information based on the numbers that you put in. So I'm going to show you right now how to do that. So the ... here, this is just to indicate to MATLAB that we're going to the next line, because I didn't want to have a very long variable. That's it. Now what we want to do is see what happens when we have a cash flow negative. So for that, we're going to increase the spendings. So for example, if we put 4,000 here, well, the cash flow is definitely going to be negative. So let's run the script again. And here we see that the message that is displayed is the one from that condition. So that does mean that we went there, and that means the script works the way we want it to work. So although that can seem like a basic thing to do, going into every condition is one of the most important principles of testing a script. If you're going to test the script and you want to make sure that there is not going to be any unexpected thing happening, you want to make sure that you're going to test every single condition. So here we have 2 conditions, right? But we can have 3, 4, 10, 1,000, 10,000, and then you have to test all of them if you want to make sure that you're not going to have any unexpected thing happening. So now I want to show you how to make the script a little bit cleaner, because if I run it again, then it starts clogging the command window, and we don't want that to happen, because if we do it a lot of time, it's starting to make it a little bit more confusing to know what script you run right now. Because when you have a lot of scripts, it's not really clean to have your command window being like full, right? So what are we going to do? We're just going to use the 2 commands that I talked about earlier at the beginning of the script, so that everything is cleaned up every single time we run the script. And let's try to run the script again. And you see it's way cleaner. And now we can run it as many times as we want. We're always going to have the same thing in the command window. So this script might be the basis for your own budget generator, because when you have your cash flow, you can calculate how much you can spend and you can create a budget. All right, so now let's move on, because vectors are a really important part in MATLAB, so we're gonna start talking about it. So let's clean everything and let's get started. So what is a vector? A vector is just a bunch of numbers put together. So there are 2 ways to define a vector in MATLAB, either as a row or as a column. So let's start with the row. You separate the numbers with spaces and you enclose them with square brackets. Now, if you want a column vector, you do the exact same thing, but except that you separate the numbers with semicolon instead of spaces. And here you have a column vector. For now, we're going to focus on the row vector rather than the column vector. So let's clean everything up and let's define again that vector. And now the first thing we can see is how can you access one of the value inside that vector. And so all you have to do is choose the index in that vector. So for example here, the 4th value is 4. So you put that index in between parentheses. So vector 4, and you have 4. So this is the value and this is the index, right? Here, the index and the value are the same, but if they were different, those would be different numbers. Now, how do you access the last number of that vector? So here, that last number is 4. So you could do what I just did now, which is put 4 in between parentheses, but you can do it another way. You can use the AND keyword and you have the same result. Now, in order to access all the elements in a vector, you use the colon as the following. And if you want to delete one number inside a vector, what you can do is you select that value using the parentheses to access it, and you replace it with empty square brackets. So for example, here we deleted the 3rd value inside the vector. We used the index 3 to get to that value. So you use the index you want and it's going to delete the value inside that vector. So at this point, you know pretty much everything you need to know about vectors, but this is just as a reference. So I'm going to show you how to define a vector just based on increasing numbers. So for example, here, if you want to redefine that vector, you can see that the numbers are increasing, right? So how can you do that automatically? Basically, you can do it by using the colon. So let's redefine that vector because right now there is a third element missing. So you go where you want to start from, colon, and then you put the number where you want to stop. And so you redefine that vector. It's a row vector by default. Now, how can you make it a column vector automatically? For that, you use the single quotation mark and you put it at the end of any vector, any row vector, and it's going to transform it into either a column vector, or if it's a column vector, it's going to transform it into a row vector. So let me show you. This is the transpose operation, right? You just add the single quotation mark at the end. So that's it. So now let me show you something that can be useful sometimes. As I said, it's not necessary, but it's just as a reference. So let's define a vector that goes from 100 to 105. All right, so this vector has 6 values, right? But let's say we want to get the value from the 4th to the n, those 3, right? 1, 2, 3, 4, 5, 6. And if we say we want from the 4th to the n, this is those ones, right? How do we do that? We can do it as the following. So we put the index that we want to start the extracting and we put it to the end of our vector because that's what we want. But if we wanted to have the 4th and the 5th, we could have written 5 instead of end here. And now let's do something else. We can extract a vector based on the values of the vector, not based on the index. Here we were looking for the index, but we can use the value instead. So let's say, for example, that we want to extract all the values that are above 103. We basically put the condition in between parentheses. You have 104 and 105 who are strictly above 103. So those two. So that's all I'm going to talk about on the topic of vectors defined with numbers only, because I don't want to overwhelm you with details that don't matter. So now we're going to talk about cell vectors. So let's clean everything up and let's get started. So first, let's get started with what is a cell and what we use cells for. So a cell is anything that is inside square brackets. For example, so even though one is a string, remember that a string is just a word basically, and the other one is a number, both are cells. And so what are they used for? Well, mostly to define cell vectors with strings. And you might think, well, can't we do the same thing as with numbers? Meaning just putting the words that we want with spaces in between and enclose them with square brackets to create vectors. And I'll show you that you can. So you see the problem here. It doesn't work because, as I said before, that's what you do when you want to concatenate words. That's not what you do when you want to define a vector. So cells are a solution to actually define a vector. So let me show you how you do it. And now that works. We have a vector of size 3 instead of a vector with everything that is concatenated. And this vector works the exact same way as any vector defined with numbers. So for example, if we want the second element of that vector, which is the word speed, we can access it as the following. Now the only difference here is that we get access to the cell, not the actual value. If we wanted to get access to the actual value, we use curly brackets instead of parentheses. And here we have the actual value. So now that you know how to create cell vectors and vectors of strings, I want to show you how to concatenate vectors because this becomes very interesting and I'll come back to this point later. But right now, let's see how to concatenate vectors. So let's clean everything up and let's get started. Let's create two vectors, v1 and v2. So these two are row vectors, so we can put them together by just putting them literally next to one another and enclosing them with square brackets. So for example, And there you go. You have concatenated those two vectors. Now, how do you concatenate them as a column vector? Well, you can transpose those two vectors using the single quotation mark that I showed you earlier and putting them one under the other and enclosing the whole thing with square brackets. So v1 single quotation mark, which means the whole thing is now a column vector. And then we want to put v2 under v1, so we put a semicolon and go back to where I talked about how to define a column vector earlier in this video, if you don't know what I mean, and then single quotation mark to make it a column vector. And there we go. All right, now we know how to concatenate vectors, so what's the point? Well, the point is, now that we know how to define cell vectors, and specifically vectors of strings and vectors of numbers as cell, well, we can concatenate them because they are of the same type. So let's do that. So this is just to show you the value of cells and what you can do with it. So I'm going to show you a few things with vectors. They are really useful when you need them, but you don't necessarily need them that often. So I'm not going to spend too much time on it. Let's get started. So let's start with redefining the vector from 1 to 4. How do you find the maximum value of that vector? Here, the maximum value of the vector is 4, right? Well, you can use the max function to do that. There you go. Next one is, how can you use a conditional statement inside a vector? For example, what if you want all the values that are above 2 but are strictly under 4? We've seen that earlier on, but we can define a condition inside a vector, and we do that as the following. We put the condition in between the parentheses. And there you go. You have all the values that are above 2 and under 4. So we know how to find the maximum value of a vector, but how do you find the index of the maximum value of the vector? So here, the maximum value is 4, and the position of that value is the 4th. So we should find 4. And that's how you do it. And now, how do you find the index of the value in a vector? For example, let's say we want the index of the value 3. How do you find that? And so that's how. So we have to be careful here because the two values are the same, but they don't represent the same thing. The answer here is the position or the index, whatever you want to call it. And what is inside the parentheses is the value inside the vector. All right, next one. How do you know how big a vector is? How many elements is there in a vector? So this one is very important, and you're probably going to have to use it a lot. Now you can also know the magnitude of a vector using the norm function here, and you can sum every element of a vector using the sum function. Let's define a vector called I that goes from 1 to 100. And the sum from 1 to 100 of all the elements in the I vector is 5050. And if you want to do the sum from 1 to n of I squared, you can do it as the following. You keep the I vector, but you define the sum as the following. You have to be careful of the dot here, because basically the dot means that you apply the square at every element in the vector. There is also a function that can be useful, which is a function that reverses everything in a vector. So for example here, the numbers inside that vector are now decreasing instead of increasing. So this one can be used for any type of vectors. So cell vectors or strings of vectors, which are also cell vectors as we've seen. You can also use it for like concatenated vector or any kind of vector you want to use it on. So you probably won't need more than that to keep going. On the topic of vectors, you're done now. So let's clean everything up now. Congrats, because you now know the foundations of Matlab and you have everything you need to move forward. This was a very condensed video. So there are a lot of things that are just to use as reference and that you are not going to need right now, but you have the tools now to move forward as fast as possible. So relax and don't get overwhelmed by what we've seen. We're going to come back to it and we're going to reinforce what we've learned. Now, if you are an engineer or researcher or you plan on becoming one, then I have something that might be able to help you. For the past 10 years, I've been working with Matlab, and I wrote a book about it just to reference everything that I've learned. So it's 10 years condensed into a book. And so that's why I made it very small, just so that I can find the things that actually matter. Because on the internet, the problem is not that there is not enough information. The problem is that there is too much information. For example, in the book, I show you how to generate and extract Excel reports automatically, create graphical user interfaces, manipulate files and documents, and I'll give you the best practices of coding I've acquired in the past 10 years. So just to be clear, this book is more for people who are working actively with Matlab. If you're going to use Matlab once a month for an hour or two, then don't buy that book. This is not for you. This is specifically for people who are going to use Matlab to do things with it. Alright, so next week we're going to see how to actually create a budget generator with Matlab. So have a great day and see you next week.